Section 7.3 is going to talk about another type of transformation, rotation. So we've already talked about a reflection. We have mentioned what rotation is, so you're already comfortable with that word. And then we'll end up talking about translations as well. Okay, so those are the main three. Now, what is a rotation? It is, of course, a transformation, and it says in which a figure is turned about a fixed point. I think, to me, a key word for rotation is that word turned.
Yes. And they use that vocabulary about a point, around a point. Same idea, but that's the vocabulary you're going to see in your book.
Now, it says, for rotation, notice it says you're turning about a fixed point. What we call that fixed point is a center rotation. So in order to rotate, you have to know what you're rotating around or about, okay? The other thing you need to know is the angle of rotation. Right? Now, how would you describe that?
So it's telling me just usually at angles we think about degrees. So how many degrees am I turning?
Yeah. So how much you're turning? Because they're not going to just say rotate. Well, because you could keep rotating and rotating and rotating. All right. Angle of rotation is going to specifically tell you the how much. Now, the way they're going to word it, and we'll kind of show you this when we do a rotation actually, it is the angle that's formed by the rays drawn from the center of rotation to a point and its image. So if you can imagine, you're drawing a ray from the fixed point, the center rotation, to the pre-image as well as its image. Okay, so that's going to form an angle, degrees. All right, so the amount of degrees the figure is rotating. Okay. So you have to know that as well. All right, now it also says in a rotation that the distance from your pre-image to the center rotation, so that distance from the pre-image to the center rotation, and you'll be told what that center rotation is the same as the distance from the image to the center rotation as well. So if you draw those distances in, they should be the same if you correctly rotate.
Okay. Now, we've talked about rotation being a type of a transformation. Well, we've kind of seen this vocabulary before, that transformations are isometries. Well, a rotation is an isometry. So our theorem, all the theorems this chapter are going to be nice and short, rotation is an isometry. What does that really mean? What is an isometry?
Okay, an isometry is after you perform a transformation, in this case the rotation, your pre-image that you started with and the image that you end with are congruent.
Exactly, and that's all that's telling us. And within that, we could talk about all of the segment lengths are the same, all the angle measures are the same, the figures are congruent. We're just noticing that it's been turned, it's been rotated around a certain point.
And you think about like on a car, the wheels rotate. When those wheels rotate or tires rotate, they're not changing shape or size.
Right.
The hands on the clock, when they move, they're just moving to a different location. It's not like they're getting bigger or smaller.
Right. Okay. Exactly. Rotations can be done either clockwise or counterclockwise. Your book will always, or frequently uses, I shouldn't say always use, but frequently it uses counterclockwise. So we're going to assume counterclockwise if it's not stated. Typically it will be given to you because you really do need to know the direction that you're going to be rotating. Sometimes if they say rotated 180 degrees, would it matter which direction I technically rotated it?
180 degrees, no.
So sometimes it won't necessarily be listed because it wouldn't matter. Okay. But you're going to see either a CC, that's going to be our abbreviation for counterclockwise, or the word clockwise.
So let me recap. So for a rotation, you need to know what it's rotating about, the fixed points, fixed point, or the center rotation. You need to know basically the direction, which is your degree amount. Not direction, counterclockwise or, I'm thinking counterclockwise or clockwise. Or you need to know basically the amount, which is your degree amount, the degrees.
So those are the three things you're going to need. And you will need all three of those things to really rotate.
Okay.
Okay.
Now, one more vocab term, and then we'll actually do some rotations on a coordinate plane like we did with reflections on a coordinate plane. There's something really cool that you can do and hopefully help you be able to do this on your own. Now, rotational symmetry, we've seen the word reflectional symmetry before. Now, rotational symmetry is a little bit different. It says a figure will have rotational symmetry. Now, not every figure out there has rotational symmetry.
Right.
But when it does, it will be mapped onto itself. So think about what that means. By a rotation of 180 degrees or less. So they do have a restriction on the amount of degrees, and we'll kind of explain that in just a minute.
Okay.
All right. So here's an example. Right? And sometimes, guys, it's hard to visualize this, especially since, like this square right here, it's hard to see it actually rotate. So we did something where we're going to show this. It also helps to maybe even turn your paper. Or I know in the classwork, they even say it might help to trace the figure and actually perform the rotation that way. So that can help. Now, this says it's a square has a rotational symmetry of 90 and 180 degrees. So they're telling you this is the amount or the two types of rotational symmetry.
Okay.
Now, if I draw in, kind of imagine kind of a coordinate plane here, and I'm going to actually physically rotate this square, all right?
Okay.
So they're saying it's happening. It's going to happen. All right? We're going to rotate it 90 degrees. Which direction?
Well, they don't specify. And the reason that they don't specify is because it could be 90 degrees either way.
Okay.
So let's go counterclockwise.
Okay, counterclockwise. That means I'm going to have to rotate my figure. Is that this way or this way?
The first way.
First way. So kind of down this way. You can think about a clock. Hopefully you know what a clock looks like. So counterclockwise is kind of the opposite direction than a clock goes. All right, so I'm starting right here. Kind of imagine. If I rotate it just a little bit, notice it's not mapping onto itself.
Right.
They're saying 90 degrees is the first amount that will map to itself, and notice that's right there.
Okay.
Now, if I connect, this is where I started down here, to the center of rotation, okay, which is basically the center of the object in this case, and connect it to where it ends, notice
it's 90 degrees.
90 degrees.
Okay.
And it mapped to itself, right?
Yeah, and those 2 points, the pre-image and the image, are the exact same distance from that center of rotation.
Good. Nice, nice, nice. All right, so they already telling you that it's obviously going to be a 90 degrees direction. Doesn't matter. Rotational symmetry. They also said 180 degrees. So so I went 90 degrees. If I do another 90 degrees, that would make 180, right?
Right.
So let me do that. I end right there. Notice I end on top of itself. It mapped onto itself.
Right.
And if I connect it, I ended up here. This is where I started. If I connect it to that center of rotation, what are you noticing?
That's a straight line. That'd be 180 degrees.
Okay.
And again, the pre-image and the image are the same distance from that center.
These distances, what she's talking about, are the same. All right. Now, why do they give you a restriction of 180 degrees or less?
Well, I'm just looking. If I had done 90 degrees clockwise instead of counterclockwise,
so if I'd started here and I went this direction, counterclockwise, if I go clockwise, which is this direction,
that would be the same thing as the 270 degrees counterclockwise.
Okay.
So because they'd be the same, when they say just 90 degrees rotational symmetry, it could be either direction.
Okay.
So if I had said 90 degrees or 270 degrees, they're the same things.
And so kind of what Ms. Huggrave was saying. So we did the 90 degrees, ended there, 180 degrees, ended here. If I do 270 degrees counterclockwise, I end here, which you're like, well, it maps to itself. But that's the same thing, what she's saying, as the 200 or the 90 degrees clockwise. If I go turn to the right clockwise, it's the same thing.
Right. And every figure would map onto itself at 360.
Yeah.
So that does not mean it has rotational symmetry.
So basically between 181 degrees and 359 degrees, there's always a corresponding degree between that 180 degrees or less.
Right.
So that's why you have to have that kind of restriction.
Okay. So now we're going to go ahead and actually perform some rotations. And in your notes, we've got some examples that we wanted to go through with you guys, and we're going to look for some patterns along the way too. I know that in the past, some of my students have said that rotations coming into this class were one of those things that they struggled with the most. But I think that after we go through and we show you some kind of tricks, you're going to realize that these aren't really that bad.
Yeah.
So the first thing we're going to do is we're going to look at the directions and we're going to see how we're supposed to rotate. They want us to do 90 degrees counterclockwise. And notice we've got that CC as our abbreviation about the origin. So we know how many degrees, we know which direction, and we know what our fixed point is.
Which is the three things that we need every single time.
Exactly.
Okay.
Okay, so using that center of rotation, we know that we want to go 90 degrees counterclockwise. I'm going to start by just putting point A on here.
Perfect.
So point A is at 1, 4.
And guys, make sure you're doing this along with us because we're going to see as we do this, there are some really convenient, cool patterns to some of these. However, that means you would have to memorize those patterns, which is not always the easiest to do. So if you really understand how to do this, which Ms. Hochgrave is going to show you really nicely, then it's going to make your life a lot easier. If you notice a pattern while you're doing it and you have multiple points to rotate, then great.
Yeah.
Okay? But sometimes it's very helpful to know how to do it without any patterns, first of all.
Exactly. So if I take a look at point A, I want to take it 90 degrees counterclockwise. So right now, this is the top of my paper. Okay, this is where I'm looking at this, just to start when we look at a coordinate plane, we know we've always kind of got our top of our paper up here. If I rotate 90 degrees counterclockwise, where would the top of my paper now be if I'm rotating it 90 degrees counterclockwise?
Okay, so counterclockwise would be going to the left in a sense.
To the left.
Okay, so I'm kind of imagining that. And 90 degrees, since the origin is the fixed point, and that's what you got to keep in mind. That's your fixed point. Because we might have some other fixed points out there. Origin's the most common. Then basically, like right over here, I'll just point to it.
Right.
That's going to be the top of your paper.
Because we know that 90 degrees, these are, the nice thing about your axes is they do form perpendicular. So we know that this will now be the top of our paper. And so I frequently will just say, okay, let's just start by identifying where is the top of my paper? Where is the top of this image going to be? Because what you're really doing is you're taking this figure and you're just turning it and putting it in the same location, but with this now being the top.
Okay.
Okay, because we're just spinning.
And notice how she rotated it. She just turned it basically to the left, basically 90 degrees.
Okay, so now we need to look at direction. So to get to point A, I had to go to the right 1 and up 4. So if this is now the top of my paper, I need to go to the right 1 and up 4. And that point right there is going to be our A prime.
Okay.
Okay. Now, looking back at my original coordinate plane, that's going to help us to figure out what our ordered pair really is, what coordinates we're at. So we're at -4, 1. Okay? And we can keep performing the same rotation.
Now, notice if you connect the pre-image to the image to that center rotation, like she's doing here. Now, you don't have to do this every single time. We did this with reflections too. Those distances should be the same.
And we could prove that if you want to use the distance manual.
Yeah. And that forms a 90 degree angle, if you can see that, right? It's more of a kind of a good visual to kind of see that.
Absolutely. All right, so point B. We're at -2, 3. So this is my point B. So to get to point B, we went to the left 2 and we went up 3. It's the same rotation. So I'm still going 90 degrees counterclockwise about the origin. So this is still the top of my paper. So to go back to, or left 2 and up 3, once I turn it, I'm still going to go left 2 and up 3. That's going to be my B prime. Okay, as we turn it back, we'll see what ordered pair that exists, and it would be -3, -2. Okay, now last point, point C, and you guys can be working ahead of me on these too. 0, -6. There's going to be my point C. To get to C prime, I know I need to go just down 6. So as I turn my paper to where this is now the top, I'm going to go just down 6. There's my C prime. So that ordered pair would be at, sorry guys, don't mean to make you sick by looking at this.
I know.
At 6, 0. Now, we could, for every single one of these, be drawing in kind of that segment that would connect the pre-image to the image, or the pre-image to the center rotation and the image to the center rotation.
That angle of rotation.
Right,
Yeah.
and you're always going to see it's going to be 90 degrees and that those two segments would be the same length. I don't want to draw too much on here because I don't want to confuse you, but I want you guys to realize that that's happening each time. All right, now, let's look at these because I want you to notice, because we noticed with reflections that there was a pattern to get from that pre-image to the image. What do you notice is happening every time with all of these ordered pairs?
Okay, so I'm gonna look. I'm looking at each pre-image and comparing it to its image, and I'm noticing. like on point A,
Uh-huh.
I see that point A, the X is the 1, and in A prime, the image, the Y is the 1. All right, and then I'm looking at the Y coordinate of the pre-image. It's 4, and in the image, the X coordinate is -4. All right, so I'm noticing it. To me, it's kind of almost like the X and Y are switching.
Uh-huh.
However, the Y coordinate of the pre-image is the opposite of the Y, of the image there. So I'm going to have switching. So it's going to be the negative Y or opposite of Y and then X.
Yeah. And does that happen every time? It's always the opposite of the Y value. This 3 became a -3. This -6 became a 6. But the X value, what now becomes your Y value, stayed the same. Absolutely. So it's a pattern. Now, do you have to memorize these patterns?
No. And I'll tell you guys, I don't even memorize these patterns.
No.
What I do often do is when I perform, like I was saying, if you perform the rotation with one ordered pair and I start noticing the pattern right away, like something triggers something, I'm like, oh, I remember that pattern. Then I can use that pattern to state the next images if you don't have to graph it.
Exactly. Okay. The important thing here is really being able to perform that reflection. Okay, so the next one. Now here we've got a new direction. We've got still counterclockwise, so not a new direction really, but new degrees, 180 degrees, counterclockwise, still about the origin.
Are we going to always do about the origin?
Not always, but typically. That's the most common that you'll see.
Yes.
All right, so if I take a look at this one, and I'm going to go ahead and put point A on there, so at 5, 1, there's my point A. And if I think about 180 degrees, all right, again, this being the top of my paper right now, where would the top of my paper be if I rotated it 180 degrees? Really, either direction.
Yeah, because this is the one where if I went clockwise versus counterclockwise, you're going to end up the same location. So 180 degrees would just be basically directly below.
So this right here is now going to be the top of my paper when I start looking at my image.
And guys, kind of imagine she kind of rotated it. If you rotate it, there's 90 degrees, okay? This is 180 degrees, another 90. So that's why that ends up being the top of your paper.
In either direction, really. If you're asked to do 180 degrees, it's just 2 90s. Perfect. Okay. Sorry, guys. We're going to make you sick over here. Okay. So if we take a look at this, to get to point A, I had to go to the right 5 and then up 1. So with this now being the top of my paper, I'll try to do it quick so it doesn't make you sick. We're still going to go right 5 and up 1. This point right here is going to be our A prime. Now, what should be true about 180 degree rotations when I look at that segment that would connect the pre-image to the center and the image to the center?
Well, if it's 180 degrees, it should form a straight line or segment, and that's what happens. And even notice, guys, those distances. Again, if we actually were asked to prove this, which we won't, but you could use the distance formula.
Yeah. All right, and as you look at your A prime, notice that it's at?
-5, -1.
Awesome. Okay, and I want you guys to go ahead and kind of work ahead.
Okay.
I want you to try this on your own. Point B is at 2, -5. So B prime, hopefully you guys found, was at? If I turn it.
Let's see.
So 2, back down 5.
So that's -2, 5.
-2, 5. Sorry. Okay.
Now, again, guys, remember we talked about this pattern. If you start noticing something, and you don't have to constantly do the rotation,
that's okay.
I would encourage you to consider that. I'm noticing
unless they ask you to graph it.
Yeah, but you can also
check
it with the graphing.
What do you notice on this one?
I'm noticing basically so far with the two that we have, the X and the Y coordinates just are opposites of each other. They don't switch, they're just opposites. So my prediction on C prime would be 3, 3. That's what I'm thinking it's going to be.
Okay. And so you're saying it's going to be just the opposite of the X and the opposite of the Y. All right, well, let's check that prediction. That's a great thing to do. So we said C was at -3, -3. So to get to C prime, we're still going to go left 3 and down 3. So here's my left 3, down 3. And was that at the ordered pair of 3, 3?
Yep.
Yeah, perfect. So I love how we kind of just stopped and make that prediction because I think that's going to be helpful too. All right, we have one more set of rotations of a different degree, and that's going to be 270 degrees counterclockwise about the origin.
Can I show you my other way?
Yes, I think that would...
just to give options, because like Ms. Hograby said, sometimes rotations can be tricky for students. And Ms. Hograby showed you a great way of just kind of figuring out what's the top of your paper. I'm going to show you a way of kind of doing it actually physically rotating, and this is actually a way a teacher taught me years ago. So it stuck with me, and it's can be convenient. Okay, so we already know the direction and the about the origin is the same as the two previous. It's the degrees that are different.
Now, I really said that this is all 3 that we're going to be focusing on because we're not going to worry about 60 degrees. We're not going to worry about 30 degrees. We're not going to try to get nitpicky with you guys. We're going to make these easy rotations for you. But notice that if you do 90 degrees clockwise, that would be, 90 degrees counterclockwise, that's really the same as what?
That would be 270 degrees clockwise.
Right. So I just want you guys to realize that by doing these 3...
And this one is really the same as the clockwise. We already established that. So this one, 270 degrees counterclockwise about the origin would be the same as
90 degrees clockwise. So just realize that these can go kind of either way. It's just that a 90 degrees of one direction would be 270 of the other direction.
So I'm going to go ahead and plot point A. It's 6'3". Make sure I graphed it right.
Yep.
And 270 degrees counterclockwise is the same thing as 90 degrees clockwise. So we could go either way. I'm going to stick with the 270 counterclockwise since that's what they said first, but you'll see it the same way.
Yeah.
So I'm actually going to physically rotate my paper, okay? So if I'm rotating it, all right, 270 degrees counterclockwise, what direction am I going to have to turn it?
Counterclockwise, you're really going to the left.
To the left. So I'm going to go kind of in this direction here. And I'm going to turn it 270 degrees. So that basically means if I turn it kind of my paper where it's horizontal, that's only what?
That's
only, I'm
that's
so bad
only
at
90.
these things. That's only 90 degrees. Okay, so I got to turn it basically 2 more times.
So you're turning your paper to the left. Rather than writing to the left, you're turning your paper to the left.
I'm actually performing the actual rotation. So right now, how many degrees have I gone?
Well, 180.
Only 180 degrees. So I got to do it one more time, one more 90 degrees. And that's why we stick with these 90-degree increments. It's just so much easier to deal with.
Okay.
So I end up with basically 270 degrees counterclockwise. Okay. Now, the way you can kind of think of this is now notice, kind of imagine this is your coordinate plane.
Right. So this is the top of your paper. So like if we just moved our pencil the 90 degree or 180 degrees counterclockwise, or sorry, 270 degrees, which one are we on? 270 degrees counterclockwise, we would have written top over here. Okay. So now it looks a little bit different because we turned our paper differently. So I just want you guys to realize where we're at.
Okay. So this is your kind of your y-axis. This is your x-axis. So notice that where my point is located now. If I go and look at my coordinate plane, it's to the right 3 and down 6. So kind of remember that. Right 3, down 6. So right 3 would be 3, and then down 6 would be -6. So if I plot that on my coordinate plane, 3, -6, that's my A prime. And I connect to show that here, those distances are going to be the same. This is your 270 degrees counterclockwise, or if you think about it, this is 90 degrees clockwise if you would have gone that way. Okay, so either way, I mean, it's just kind of your preference.
Yeah.
Right? And this is where, I mean, Ms. Hograby teaches it one way, I show the other way.
And they both work.
They both work. It's just what you're kind of comfortable with.
Right. Because on here, if I had written top of the paper over off to the side here, I would have gone right 6 and up 3, and here you would still be going right 6 up 3. It accomplishes the exact same goal.
Yeah.
Just 2 different ways to go about it.
And I think, to me, guys, one thing that helps me is you don't have to draw in these segments, but it's a good kind of a way to check. Did I really do the right rotation? Did I really do it right? Okay, so let me just show you another one like that just to be exposed. All right, so -1, 2 is your B prime. Or B, sorry. And if I want to do, let's say, because instead of 270 degrees counterclockwise, that's turning my page 3 times. I'm going to go 90 degrees clockwise because it's the same thing. So I'm going to turn my page basically to the right this time once, because that's the same thing as 270 counterclockwise. And I look at my coordinates. So this is kind of my y-axis. This is my x-axis now, just kind of how you're looking at it. It's like that top of the page, like Miss Hochgraby did before. So my new coordinates are going to be 2, 1. Okay, right 2, up 1, right 2, up 1. So 2, 1, and I'm going to plot that point. There's my B prime. And notice if I connect them, there's my 90 degrees clockwise or 270 degrees counterclockwise. All right, now, because we've done 2, Ms. Hochgraby, make a prediction. Can you make a prediction?
I think so. Looking at these, I noticed that kind of like the very first one we did, the X and the Y are flip-flopping positions in terms of a 3 and a 6, but I also noticed that it's the opposite of the X value.
Okay.
So I'm going to say,
so what's your prediction here?
It's going to be a, let's see, I'm still going to have a -5.
Okay. And
but it's going to be -5 comma +4 is going to be my prediction.
So basically these coordinates switch spots.
Yes.
And the X value of the pre-image is the opposite.
Right.
So if I wrote that,
it would be Y comma -X, or the opposite.
Because they switch and the opposite of the X.
Okay. So let's check it. Let's make sure.
So C is -4, -5. And I'm just going to go ahead and put -5, 4 down here. Or up here. It should be up here. And C. Let's see. What do you think? If I connect those to that origin, which is the center of rotation.
Yeah, and we see either 90 degrees.
Now, one thing to notice.
Clockwise.
Yeah, you're going 270 degrees counterclockwise. So that would be to the left. That's counterclockwise. Or clockwise 90 degrees. There's where you're 90 degrees clockwise. Now, I know, and I'm just thinking of this. I know the biggest mistakes with the rotations is the direction.
Yes.
Don't you see that in the past?
Absolutely.
So really be careful with that direction. If it says counterclockwise, make sure you're really thinking counterclockwise.
And if you look at which is your pre-image and your image, so looking at which is the regular, which has the prime, make sure that to get there, you're going that direction. So we know that to get from C to C prime, that's either 90 degrees clockwise or 270 degrees counterclockwise.
Yeah, and like she's showing yourself. This is what she's showing there.
Yeah. Okay, now we have just a few more, and we just kind of put down a quick synopsis of what we already have stated. When we had a rotation of 90 degrees, what did we say happened to our ordered pairs?
It became -YX.
And when we had a rotation of 180 degrees?
It was just the opposite.
Oh, yeah, I did put counterclockwise.
Yeah.
It was just the flip-flop of them, right?
Yeah.
So it'd be Y comma X.
No, it's the opposite.
Opposite of X comma, I'm losing it. Opposite of X comma, opposite of Y. And rotation of 270 degrees counterclockwise.
So it'd be Y -X. So it's the flip and then opposite of X.
Okay, so just a quick synopsis of that. Now, you guys can perform these rotations. Try them on your own. I want you to pay attention to direction because on some of these we threw in a clockwise instead of a counterclockwise. But we want you to try those 3 on your own just to make sure that you guys are comfortable with it. And then once you're ready, go ahead and hit or unhit pause and we'll talk you through it.
Okay.
Okay, so we said G was at -4, 1. So to get to G prime, where did you end up?
All right, so that would be the same as the 270 degrees counterclockwise. All right, so that would be this one. So I'm going to say it's going to be, sorry, the screen froze on us. So you have to switch it, and then the X becomes opposite. So it'd be 1, 4.
Perfect. And if you guys performed that 1, 4, notice that did go, we did 90 degrees clockwise. So if I drew in my segments to the center, it is 90 degrees and it is going in the clockwise direction.
Perfect.
Okay? And again, however you turn your paper or do tops, it won't matter to us.
Does not matter.
All right, next one. Here we had 180 degrees, either direction really.
Yep.
Again, about the origin. So J was at 1, comma 1. So where did you go to get to J prime?
J prime is going to be -1, -1.
And if you again draw that in, you're going to notice that if I drew in that segment to the center, they make a straight line, which makes sense because it's going to be 180 degrees. All right, what about this last one?
All right, so again, that direction is the key. It says 270 degrees clockwise about the origin. All right, so if you're actually performing the rotation by the graphing way, or if you're looking at your patterns, and again, guys, the patterns are only helpful if you actually know them. All right, so it really encourage you to perform the graphing and then checking. All right, so 270 degrees clockwise about the origin is going to be the same thing as 90 degrees counterclockwise. So it's going to be flipped, and then the y is going to be opposite. So -4, -2.
And again, you can perform that rotation, and we'd like you to. Just use whatever method worked best for you. And -4, -2, if you go ahead and put that point on there for M prime, you're going to notice that, yes, they do make a 270 degrees clockwise rotation.
Perfect.